All right. So, again, I don't know if this was in your notes or not, but Newton's law of cooling. T minus T sub S equals T sub 0 minus T sub S times e to the negative KT. T0 is the temp at time T equals 0. Surprise, surprise.
In parentheses, it says tots.
I used to hate standard tots. Or we go to Sonic and they said, I was like, Dad, you better make sure they switch my side to fries. I did not want those standard tots.
Yeah, I don't really like them that much. I've grown to like them more in the last year, I would say.
Yeah.
But I like the round discs like Chick-fil-A has,
Yeah, I
not
like
the
the
fat
cash
ones.
ones. Yeah. I like the little cups.
All right, 32. Cooling silver. The temperature of an ingot, I don't even know if that's how you say that word, but
I would call it ingot.
Is it on like
Ingot.
trap?
of silver is 60 degrees Celsius above room temperature. Right now.
I like how they specify right now.
20 minutes ago, it was 70 degrees Celsius above room temperature. How far above room temperature will silver be? Dot, dot, dot. A, 15 minutes from now. Actually, I'm going to leave some space and write. What?
You said leave space.
I'm just leaving one line to write, what all these things are from the problem. Because I'll need it going through, basically. So T sub S is 60 degrees. That's the current temperature. T sub 0 is the initial temperature, which is 70 degrees. And it's 20 minutes before, so T equals 20. So T minus T sub S equals 60, and T sub 0 minus T sub S equals 70. So now, T minus T sub S equals T sub 0 minus T sub S times e to the minus KT. That's just writing the formula. I probably won't write the formula again going forward, but for this one I will. So then this is 60 equals 70 e to the negative k times 20. So then e to the negative k times 20 equals 6 over 7. Use a log. So I get the ln of 6 over 7 equals negative 20k. So the ln of 6 over 7 all divided by negative 20 equals k. Also, technically, I'm realizing based on what they're actually asking us, this is really just the setup, but it'll be the setup for every problem or every part of this problem. So technically speaking, like, part A is going to officially start down here, just so that we're aware.
.0077.
So now I'm using that with K. And so I'm going to be plugging this into this formula to solve for 15 minutes from now. So I'm going to be solving for the T minus T sub S in this case. So let me actually come down here now. So I'm going to have T minus T sub S equals 60 e to the negative 0.0077 times 15. And then I would just type that in, and then that'll give me the temperature that I'm looking for.
Do you want us to use the ln thing or the decimal?
It shouldn't make that much of a difference. The 53.5 degrees Celsius above room temperature 15 minutes from now. And technically all you need is the 53.5 degrees Celsius. I'm just specifying what we were actually finding since I kind of like moved the problem down. So then part B is 2 hours from now. But obviously we've been dealing in minutes, so how many minutes is that?
120.
Yep. So 120 minutes is what I'm going to want to use. So T minus T sub S equals 60, not 0. E to the negative 0.0077 times 120. Now I didn't really say this, but we would want to mention above room temperature in our answer. We don't necessarily have to put the time frame down because that was part of the question. So obviously if it was negative, I would want it below room temperature. And again, above room temperature. Then part C says, when will it be 10 degrees above room temperature? So what am I actually trying to solve for this time? Yep. So T is what I want to find. So that means my T minus T sub S in this case is 10 because that's what I'm ultimately trying to find. So 10 equals 60 e to the negative 0.0077 T. So e to the negative 0.0077 T equals 1 over 6. Ln of 1 over 6, I'm going to go ahead and do divided by negative 0.0077 equals T. I was looking because there's a problem in the book that says dating Crater Lake, and it like has this thing about figuring out how old it is. And our book says that it's like 6,658 years old, which like probably reasonable, like, or like a reasonable approximation at least. But anyways, so I was like Googling it because I could have sworn when we were at Crater Lake over the summer that they said that it was like 1,000,000 years old or something. So I was like going to look, but it says that they assume that it's about 7,700 years. So.
Where is that again?
Oregon. It's beautiful.
I want to go there.
But depending on when you go, like when we were there in
We
June,
went
there was
July.
snow. Okay, yeah. There might still be snow when you go. A bunch of it was closed when we were there. Anyways, I was just looking because I wanted to see how like close that possibly
Yeah.
was. Because it's about like dating a tree that died or something at the same time, and it was like checking the carbon in it. Anyways, random side note. In addition to the problem you had yesterday, or the problem you had yesterday, just add 31 to it. It's cooling soup instead of cooling silver this time. I will also note that my book has a typo in the answer. So if you check your answer and you're off, just ask and I can tell you, because last year we did this problem, like several people did the problem, and then I worked it out and I got a totally different answer than the book, and so did everybody else. So I'm pretty sure there's a typo in the book, but I don't know if y'all's has one in the back or if it's just mine. So, because sometimes the teacher book is different than y'all's. I had a class trying to tell me the other day, y'all would find this funny.